Okay, so for the 2017 exam, question number 1 on the free response, they're giving you a situation where you have a tank, all right, and it's 10 feet high. And then they tell you in this table that at the height, what the cross section of the tank is, the area of the cross section. Okay, so like at 0 feet, it's 50.3 square feet. And so that'd be the base of the tank, all right? And then 2 feet up, it'd be 14.4 square feet, all right? So they're giving you all of this information, okay? They're telling you this function a of h is continuous and decreases as h increases, okay? So as h increases, a of h keeps decreasing, okay? Which would mean the cross-section area, as you go up in the tank, it would have to be getting smaller and smaller and smaller, okay? All right? And so they tell you h and a of h are given in the table above. And then part A, use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank. So volume is in cubic feet, right? Okay, so if we multiply square feet times the feet, we're going to get cubic feet, and that's how you're going to find the volume of this. Okay, so I'm going to go to my paper and we're going to work this one out. So this is going to be an integral, all right, and it's going to be a of h, and those units are square feet, and then we're going to integrate with respect to h, so dh. And so since the h units are feet, this is feet, and this is square feet, so when we go to multiply these, that's going to be feet cubed, which is a volume unit, right? Okay, now we're going to also integrate this from 0, because that's the bottom of the tank, all the way up to 10. So we're going to accumulate all these areas from 0 to 10, okay? And we're going to do that with a left Riemann sum. So this is going to be approximate, okay? And if we're doing a left Riemann sum, that first width from the table, okay, that first width goes from 0 to 2, and we're going to use the left side, so it'd be 50.3. That's the height of it, okay? All right. So you could also do it like this: 2 times h of, no, not h of 0, sorry, a of 0. Let me erase that. Okay, so times a of 0, and then plus, and then the next interval goes from, I'm going to slide this up, 2 to 5, so that's 3. So these are unequal intervals, okay? So 2 to 5 would be 3, so that'd be plus 3 times a of, and that would be 2, because that's the left side. And then the next one is from 5 to 10, so that width would be 5, okay? So plus 5 times a of 5. Okay, because that'd be the left side. Okay, so from the table, this would be 2 times, and a of 0 is 50.3. I'm just reading this off the table. Plus 3 times a of 2, which is 14.4. And then plus 5 times a of 5, which would be 6.5. Okay, so we would just put this into our calculator, all right, because you're going to be able to use a calculator on this, okay? So I'm going to just, because it's just a calculation, I'm just going to pull my calculator up here, okay? Okay, and then I'm going to type in just 2 times 50.3 plus 3 times 14.4, and then plus 5 times 6.5. Just double checking to make sure I'm typing it in right. Okay, and 176.3, okay? So the volume of this would be 176.3. And okay, remember, this 2 right here is feet. This a of 0 is the 50.3. That's square feet, right? So it's given us the right unit. So this is feet cubed, okay? And that's the correct answer for part A. So for part B, does the approximation in part A is an overestimate or an underestimate to the volume of the tank? Explain your reasoning. Have you noticed that this question has come up several times, okay? So and a lot of times they'll ask you when you're doing like a left Riemann or a right Riemann sum, they'll ask this question, okay? So here's the key to answering this, is reading that the function A is continuous and decreases. Okay, so it's decreasing And the other thing is we're doing it in part A, we did a left Riemann sum. So I'm going to draw a picture again to help explain this, okay? So that you'll get this right on the test, okay? All right, so for part B, okay, I'm going to come off to the side here. Okay, so we have this graph, okay? And we know A is decreasing, right? Something like this, right? Decreasing, okay? And if we're doing a left Riemann sum. So if we do a left Riemann sum, that's going to come up here on the left side and stop at the height of the function, right? And then we're going to go across and then back down, right? And you see this little part right here, that's going to cause it to be an overestimate, right? And it's because we're doing a left Riemann sum on a function that is decreasing, okay? So the estimate, because the 176.3 is an estimate, in part A is an over estimate because A of H is decreasing and a left Riemann sum was used. I think it's 2 n's for Riemann. Yeah, Riemann sum was used. If you spelled it wrong on the test, it's not that big a deal. Okay, and that's the answer to part B. Okay, so let's go to part C. Okay, so for part C, the area in square feet of the horizontal cross section at height h feet is modeled by the function f given by f of h is equal to this, okay? So this is the area function, okay? So it's a brand new area function, okay? So this is just like a of h, but it's an actual formula, right? So this is really the exact same question as part A, okay? This is gonna be an integral, okay? Because we're gonna find the volume of the tank, okay? So let's go back and we're gonna use our calculator to integrate. So that's a good thing, right? Because what does it say up here? A graphing calculator is required for this, okay? All right, so let's go and do this knowing that f of h is 50.3 over 0 raised to the 0.2 h plus h, okay? Let's go ahead and do that. Okay, so for part C, all right, we know we're going to take an integral, and it's f of h and then dh. Okay, this is my width, right, which would have to be feet. Okay, and this is my cross section area, which is in square feet. So if I take square feet and multiply by feet, I'm going to get feet cubed, and I'm going to integrate this from 0 to 10, okay? So that's equivalent to the integral from 0 to 10 of, and then we were gonna write, I'm gonna write 50.3, this is actually the f of h function, okay? And then over e to the 0.2 h, and then plus h, and then dh on the outside here. Okay, so we're gonna put this into our graphing calculator, and what this is gonna do is it's gonna give us the volume of this tank, okay? So I'm gonna go to my graphing calculator and show you this. All right, a lot of times we're going to use this function f of h for other things. So that's why I would always put these functions into the y register, okay? Or the right y editor. So I'm going to clear out what I have here. Okay, so y1 I'm going to let be the 50.3 over and then e to the 0.2. We're going to have to type in x instead of h. So 0.2 x. I'm going to come down and then plus x. Okay, make sure you're not still up here in the exponent, because I know I've done that a lot. Okay, make sure you come down after the exponent. All right, and then let's quit this. Okay, and now we're going to integrate. Okay, so alpha window number 4. We've done that so much we just know where it is, and we're going to integrate this from 0 to 10 because the tank is 10 feet high. Okay, so we're collecting all of these cross-section areas from 0 to 10. Okay, and so this was y1, so alpha trace y1, and then dx. And press enter. and 101.325. Okay, so we're going to go back and we're going to record this on. Okay, so this was 101.325. And what were the units for this? Okay, again, this is square feet, right? I'm going to do this in a pinch so you see it. This right here, this f of h is square feet, so that'd be feet squared, and the dh is feet. So when we go to multiply these, right, we get cubic feet, right? So that would be the units for this, feet cubed. Okay, and that's the answer to part C. We're done with C. Let's go on to D. Okay, so water is pumped into the tank when the height of the water is 5 feet. So that's h equals 5. I'm going to write on this. So that's h is equal to 5 right here, okay? The height is decreasing at a rate of 0.26 foot per minute, okay? So the height is decreasing at a rate. So that's the height rate, right? So this is dh over dt, okay? And we know that is the height is increasing, right? So that's a positive rate, and it's 0.26 feet per minute. I might have said decreasing a few minutes ago or a few seconds ago. I meant increase, okay? The height is increasing at a rate of 0.26 feet per minute. So that's 0.26 feet per minute. Okay, so we know these two things. Using the model from part C, okay, find the rate at which the volume of the water is changing with respect to time when the height of the water is 5 feet, okay? So we want to find from this, we want to find D, basically dV dt, okay? Find the rate at which the volume of water is changing. So we want to find dV dt with respect to time when the height of the water is 5 feet, okay? Indicate units of measurement. So we're going to go ahead and do that now. Okay, so what's hard about this problem is, and that's why you heard me hesitate there, right? And I had to think a little bit, okay? We're trying to find dV dt, right? And at t equals 5. No, at h equals 5. I'm sorry, h equals 5. Okay, and then we also know that dH over dt is 0.26 feet per minute. Okay, and so we want to find dV dt. We do want to, it is dV dt because of the rate at which the volume is changing, right? And that would be with respect to time, okay? So to get dV dt, all right, we need to come up with a volume formula, okay? And the volume formula for this would be an integral, okay, function. So we know from the last problem that V of h would equal, okay, the integral from 0 to h, to whatever h is, f of h times dh, right? Okay. Wait, I got to change because we need to use dummy variables, right? So it shouldn't be h here, okay? We're going to change it to x's because h represents where we're going to stop the integration. Okay, and x just represents what we're putting into this function. Okay, so f of x dx. Okay, now if I take the derivative we could take the derivative with respect to h on both sides. Okay, so if I do that, if I take the derivative with respect to h of both sides, okay, and I do the same thing with this one, okay, this side will give me dv over dh. And let me slide this up a little bit. Okay, so this is going to give me, this left side is going to give me dv over dh. And then that's going to give me for this, when I take the derivative with respect to h of this integral from 0 to h f of x dx, it's just going to give me f of h. Okay. Now I need to make dv dt, right? So I can do that. All right. So dv over dh times, and I'm going to multiply both sides by the same thing, dh over dt is equal to f of h, and then times dh over dt. So what happens over here is my dh's cancel, and I'm going to be left with dv over dt. So this is the function for the change in the volume, okay? So I know that dv, I'm going to come up here, okay? I know that dv over dt must equal f of h times dh over dt. Okay, so I want to find this rate when h is 5. So I have dv over dt is equal to, well, not equal to, sorry. We're going to find this. We're going to know what it's equal to. So we want to find dv dt at that vertical line at h is equal to 5. Okay, so this is equal to f of 5 times the rate of change of the height. Well, we have that, right? It's constant. It's this. It's 0.26, right? So times 0.26, okay? Now remember, this is feet per minute, right? This 0.26 is feet per minute. The F units, that anything you put into F is square feet. So what we're going to get out of this is cubic feet per minute, which makes sense. That's what we should get if the volume is changing, okay? So we're going to use our calculator, and we're going to find this value right here, okay? And I'm just going to go to my graphing calculator by hand, okay? The portable one, not go to the screen, okay? And I'm going to pause for a minute because I haven't entered the function into my handheld one yet. Okay, so I put my function into y1 now, okay? And so I'm going to do alpha trace and then number 1, y1 of 5, because that would be the same as f of 5. And it's this, right? And then I'm going to multiply that by 0.26. And we get 1.694. So I'm going to record that, okay? So that means dv over dt at h equals 5 is approximately, because we're going to round, it's 1.694. Okay, and this is cubic feet per minute. Cubic feet per minute, okay? Why again? Okay, so this is feet squared, right? And this is feet per minute. And when we multiply those, that makes sense. We'll get cubic feet per minute, okay? All right, so when we want to write a statement on this, okay, when h equals 5 feet, the volume of, and I think it was water, right? Volume of water, yeah. Volume of water in the tank is, and this number is positive, so it's increasing. And I'm going to slide this up just a little bit. Is increasing 1.694 feet cubed per minute. You could also write that feet cubed over minute like this, okay? And you'd be fine, all right? Okay, so that's the 2017 exam for free response question for number 1, okay? You guys, I think part of this, part D, is by far the hardest, okay? To be honest with you, I'm going to be really, really happy if you got part A and part B. I'd be really, really happy. Okay, all right. Just know that, like, that's good. You're doing good. Okay, because I think this last one is a little bit hard. It's not really, really straightforward. It's not quite like a related rates like I normally give you. Okay. All right. So let's go on to the next problem. For the 2017 free response question number 3, they're giving you the graph of f prime, okay, and and it's a closed interval, and they're also telling you that f of -2 is equal to 7, okay? And they're going to ask you some questions. This is made up, and it's pretty clear from the diagram. It's made up of some line segments and then a semicircle right here, right? Okay. All right. So let's go ahead and for part A, let's find the value of f of -6 and f of 5. Okay. All right. We'll go to our paper and we'll do that. All right. So what's important here is that we know that f of -2 is equal to 7. Okay, because we need that fact because we're gonna integrate to get f of -6. Okay, so we know that if we integrate, okay, from let's go -6 to -2 of f prime of x dx from the fundamental theorem of calculus, we know that that has to be equivalent to f of -2 minus f of -6. Okay, so we know this one, right? We can replace this one with 7, all right? And this one, I'm going to move to the other side. Well, actually, I'm going to move this one to the other side and the integral to this side, okay? So if I'm going to add both sides, that would give me f of -6 is equal to f of -2 and then minus, and I'm going to move this integral to the other side. Okay, so that's the integral from -6 to -2. And I chose -6 to -2 because then that would give me, I'd be going from left to right when I integrate. Okay, f prime of x dx. Okay, so that means f of -6 would have to equal f of -2, which we already know is 7, minus, okay, and then we're going to do area from -6. We're going to use area to figure out this integral, okay? So I'm going to go back to the graph, and we're going to go from -6 from right here to right here, okay? So this is going to be 1/2 this height, which is 2, and then this base, right, which is this is -2 right here, okay, because we're going by ones. So this would be 1, 2, 3, 4, right? So 1/2 2 times 4. So minus 1/2 2 times 4. Okay, so that means f of -6 would have to equal 7 and then minus, and then this would just be minus 4. Okay, so f of -6 we now know is 3. Okay, and that's how you find f of -6. We're going to do something very similar with f of 5. Actually, f of 5 is a little bit easier, I think. Okay, so for f of 5, we're going to go, this time I'm going to go from the integral from -2 to 5. Now, why am I always using -2? Because I know that value, right? So f prime of x dx, okay, and I know that's going to have to equal f of 5 minus f of -2. Now this time I'm going to move this one over, okay? So f of -2, okay, plus the integral from -2 to 5 f prime of x would equal f of 5. Okay, this just bothers me. This is just me, okay? I want f of 5 to be on the left side, so I'm just going to rewrite it, all right? So f of 5 is equal to f of -2. I probably wouldn't do this if I was taking the AP exam, okay? Just because of time. Plus the integral from -2 to 5 f prime of x. And you guys, I forgot my dx right here. So there should be a dx. Okay, and then dx. Okay, so now I know f of 5 is equal to f of -2, which we know is 7, plus, and then the integral, right? Whoops, I don't need the integral. I'm going to actually figure it out. Let me take the integral symbol off. Okay, sorry about this, guys. Okay, so we want to do the integral from -2 to 5, right? So from -2 all the way to right here is 5, right? 1, 2, 3, 4, 5. That's 5 right there. Okay, so we want to go from here all the way to here. Now, all of this, because it's below, my function values are negative, and I'm integrating left to right, so all of this is going to be negative area, okay? So this would be plus, all right, and it's going to be -1/2, because it's a half a circle, pi times my radius, okay? And the radius of this is 2, So minus 1/2 pi 2 squared, okay? And that takes care of the integral part from -2 to 2. Now I want to take care of the integral from 2 to 5, right? And this is just a triangle, okay? This would be the height right here, and this would be the base. So to this, we're going to want to add 1/2, and this would be 1/2 2 times 3, right? So 1/2 2 times 3. Okay, and so that means f of 5 is equal to 7, and this is 4, and we're going to take half of that, right? So that'd be -2 pi, so minus 2 pi, and plus 3, right? So that means f of 5 would be 10 minus 2 pi. Okay, and that's the answer for f of 5. Okay, this would be, if you left your answer right here like this, that's an unsimplified answer, but it's correct. So if you stopped right here, it'd be right. Actually, even right here, if you stopped right here, you'd be correct. Okay, because you have a numeric answer. Okay, it just hasn't been simplified. Okay, so you could stop right there. Okay, all right, so that's the answer to part A. Let's go on to part B. Okay, so for part B on number 3 is on what intervals is f increasing, and then we want to justify our answer, okay? So we're going to use where f is positive, right? Or f prime is positive, okay? Because where f prime is positive, we know it's going to be increasing, okay? All right, so let's go to my paper, and I'm going to answer this, all right? All right, so grabbing the graph, okay? I know that f prime is positive from -6 to -2, including -6 and not including -2, right? Because it's 0 there. And then it's also positive between 2 and 5, right? Okay, so that's where f prime is positive, okay? Okay, so f prime of x is greater than 0 on, okay, and it would be -6, including -6 to -2, okay, and, or you could put a union here, okay, and it's also positive between 2 and 5, okay. Now, because it's positive on these intervals, okay, f is increasing on, okay, so bracket, it's going to be increasing at -6. And okay, some people, it's going to stop increasing at -2. Now at -2, the derivative is 0. I know, but we can include it there. Okay, so some people include this and some people don't. So right here, you could also, an option would be to have a parenthesis. Okay, some people include the -2, some people don't. It's not always agreed upon whether you include it or not. Okay, so they're going to accept it either way. Okay, and then or you can have a bracket or you can have a parenthesis right here on the -2. You have to have a bracket on the -6. Okay, and then it's also increasing on this and this interval. Now, I would do bracket 2 to 5 bracket. Now at 2 and 5, the derivative is 0, right? But that's where it starts to increase again, and that's where it stops to increase, okay? So again, these could be, you could also have an open parenthesis, or right here, you could have a parenthesis, okay? So there's two ways to write this. You can go bracket -6 to -2, bracket or parenthesis, and the 2 to 5, you can do brackets or you can do both parentheses, okay? All right? Maybe I should just write it like this. So you could write it like this too. So they would accept this as a way of answering it, and they would accept this way as a way of answering it, okay? And that's it. We justified our answer because we're looking for where f prime is positive, okay? So now let's go on to part C. You guys, I know on a lot of these videos, I'm doing a lot of talking and explaining, but it's really to help you prepare you and get you ready. I know it's not just the answer, it's like explaining. So these take longer than just doing the problem. I mean, okay. So I want you to understand like why we're doing it. Okay. So especially like this one. Okay. So part C, find the absolute minimum value of f on the closed interval, -6 to 5, and then justify your answers. Okay. So we have a closed interval, right? So it's the closed interval test. All right. We want the absolute minimum. Now, we can find the critical values, but you could also just check the endpoints, right? We're going to want to check -6 and 5, all right? And then we want to check, we don't need to check all of them because we're not looking for the absolute min and the absolute max. We're just looking for the absolute minimum. So this could save some time. So we're looking for where f prime changes from being negative to positive, okay? So from negative to positive. So all we would need to check is the endpoints and where f prime changes from negative to positive. So it's changing from negative to positive at 2 right here, right? Okay, at 2. So we just need to find f of -6, f of 2, and f of 5, okay? Now, why am I not checking f of -2? Okay, f of -2 is a relative maximum, right? So it can't be an absolute minimum because it's a relative maximum right there, right? Because the derivative is changing from positive to negative, okay? All right, so all we need to do is check 2. All right, so let's do that in part C. Okay, so for part C, we want to find f of -6, right? And you know what? We already figured that one out, right? I'm going to go back to my paper, okay? F of -6 is equal to 3. So you don't need to show this work again, okay? You can refer back to part A, okay? So we know f of -6 is 3. Done with that one, right? We also need to find f of 2, okay? Why f of 2, okay? Because that's where the integral, or that's where the derivative changes from being negative to positive, okay? So that means we're going to find the integral. Well, hold on. Let me, I can't write this yet. We're going to want to define this. We're going to do the integral from -2 to 2 of f prime of x, right? dx. And then that's going to equal f of 2 minus f of -2, right? So f of 2 is going to have to equal f of -2 plus, right? I'm just moving this over and I'm writing f of 2 on the left-hand side, plus the integral from -2 to 2 f prime of x dx, okay? So now what do I know? F of -2 is 7, right? Because that was told to us, all right? And then we know that this is a semicircle. Okay, so I'm grabbing my graph. So from -2 to 2, it's a semicircle with a radius of 2, okay? So that's going to be minus 1/2 pi times my radius of 2 squared, right? So that would be 7 minus 2 pi, okay? So 7 minus 2 pi. Okay, now which of these is the smallest right now, right? Okay, so this one would have to be the smallest. Pi you can estimate with being like about 3, right? So this would be 7 minus 6. So this would be 1, okay? And it's actually less than 1 because pi isn't 3. It's a little bit bigger than 3, okay? So you know this one's smaller right now, okay? So now we also need to do f of 6, right? Not f of 6, f of 5. And we had f of 5, right? F of 5, we calculated in part A, right? F of 5 from part A was 10 minus 2 pi. So this is equal to 10 minus 2 pi, okay? So if pi is about, if we're using to eyeball this, okay? If pi is about 3, this would be 10 minus 2 times 3, which is 6, okay? Right? And so this is actually less than, it's not 6, it's less than 6, but not by much, okay? So that means this one has to be smaller, right? Okay? All right. So this one is the smallest one, and that has to be the absolute minimum. So F has an absolute minimum of, and it would be 7 minus 2 pi at x equals 2. Okay? And because that's what it was asking you, right? Find the absolute minimum value of f on the closed interval. Justify your answer. So our justification is we're checking the critical points, right? Okay, and then the endpoints. Okay, all right. And if you look at the scoring on, if you were to look at the scoring on this, they're giving you a point. I'm pulling my scoring up. They would give you a point for checking this f of 2, okay, and then doing your endpoints, okay, and then writing your answer, okay. That's the second point. So this is a 2-point problem, okay. All right, let's go to D, okay. So for part D, it says for each of f double prime at -5 and f double prime of 3, find the value or explain why it does not exist, okay. So we're given the graph of f prime. So f double prime is the derivative or the slopes from the graph of f prime, right? So right here at -5, that would be right here, right? The slope right there. Well, on either side of that, the slope would be the same because that's a straight line, right? Okay. And so coming into this, the slopes on either side of this are going to be the same value. And so that would just be the slope of this entire line right here. So it's going to exist. So let's go to our paper and let's go ahead and figure that one out. Okay. So for part D, I know f double prime at -5 is going to equal, and it's going to wind up being the slope, okay, for these 2 points right here, this point and this point, right? So it's going to be 0 minus 2 over, okay, since I started with this one, I'm going to start with -2, -2 minus -6. Now, if you, on the top, if you wrote 2 minus 0 over -6 minus -2, you'd be right. Okay, so that's -2, and this would be -2 plus 6, which would be 4, and then that would give you -1/2. Okay, so f double prime of -5 is -1/2. Okay, now at 3, that's a different situation. Okay, because at 3, the left side, right, is going to be, that's going to be this slope, and the right side, this is the left side derivative. Okay, and then the right side derivative is going to be this slope right here, right, because these are made up of 2 lines. So what that would mean is f double prime of 3 does not exist. Okay, now we gotta give a reason why. Okay, so I'm going to go back to my paper here, and let's say f double prime of 3 does not exist. Okay, now we're going to use the definition of derivative at a point to figure this out. Okay, so we're going to take the limit as h approaches 0 from the left of f of f prime, sorry, f prime of 3 plus h minus f prime of 3 all over h. Okay, now what is this? This is the left-hand derivative for f prime. Okay, now there's an alternative way of writing this, and I'll show you that in a minute. Okay, but this slope right here, all right, we're going to go up. We're going to go up 2 and over 1, right? So this slope is equal to 2. Okay, and then we could also say the limit as h approaches 0 from the right of f prime of 3 plus h minus f prime of 3 over h. And that would be the slope for this one, right? So this one it's going to be negative, right? And we're going to go down 2 and right 2. So that'd be a slope of -1. So these one-sided limits don't exist, right? Or these one-sided limits differ, right? And that's why f triple prime of 3 does not exist, okay? Because the limit as h approaches 0 doesn't exist, okay? So the limit as h approaches 0 of f prime of 3 plus h minus f prime of 3 over h does not exist. Because remember, for limits, for this to exist, the one side limits have to be the same amount, right? They have to equal each other, and they don't, okay? So there's an alternative form for definition of derivative. It's on your card stock, okay? So another way of doing this is you could take the limit as x approaches 3 from the left of f prime of x. Hold on a second. Yes, f prime of x minus f prime of 3 over x minus 3. It's an equivalent of this, okay? And so this one is, this is the derivative at 3, but it's the left derivative, okay? And this would equal 2, okay? Because we're approaching 3 from the left side, right? And so some of you, this might make more sense, okay? And then if we do this one, it would be the limit as x approaches 3 from the right of f prime of x minus f prime of 3 over x minus 3. And this is the right-hand derivative, okay? And then this one would equal -1, okay? So it's just two different ways of writing the same thing, right? And then we would say the limit as x approaches 3 of f prime of x minus f prime of 3 over x minus 3 does not exist, right? And this is the definition of f prime of 3, right? So f prime of 3 does not exist. Not f prime, f triple prime. F triple prime of 3 does not exist. So this is the formal write-up of why it doesn't exist, okay? And that's D, and we are done for today, okay? All right, so you guys take care. I will see you in the next lesson.